Okay, next we'll talk about dilations. A dilation is another transformation where we're looking at expanding or shrinking our shapes. Okay, so dilations. So let's zoom in and take a look at our description rule. Oops. The figure expands or shrinks with respect to a fixed point. Okay, so now to determine if the shape shrinks or expands, here's our formula. And the formula actually is something that you don't really have to memorize. Once you understand how it works, it's really simple. So what we have here is our xy becomes k times x and k times y, where k is the scale factor. Okay, so if you had 2x, 2y, that means our shape is going to double in size because I'm multiplying by 2, right? If I had 1/2 x and 1/2 y, it would shrink because it's getting half the size. And literally all we're going to do is multiply the number times the variable. 1/2 times the x value, 1/2 times the y value, 2 times the x, 2 times the y. It's very similar to the translation in the sense that with the translation you had like x plus 3. So you took the x and you added 3. Now we're taking the x value and multiplying by 2 or 3 or whatever the value is. Oops. All right, let's look at an example. All right, example number 1. Draw the image after a dilation having a scale factor of 2. Oops, sorry. Okay, so what that means is we're going to multiply 2 by our x value and 2 times our y value. Now, up to this point, you could plot your points first and then come up with your ordered pairs. This time, we want to come up with the ordered pairs first. Okay, and you'll see why in a second. So we're going to take A and we're going to find A prime by multiplying each by 2. My x times 2 and my y value times 2. So I get 4, 6. For B prime, again, I'm going to multiply 3 times 2 and 1 times 2. It's my scale factor of 2. I get 6, 2. And then C, again, the x value times 2, y value times 2. And I know that because it tells me I have a scale factor of 2. Okay, so we'll go over and we'll plot our points. So A prime is 4, 6 over 4 up 6. B prime is 6, 2 over 6 up 2. And C prime is 2, 4. Okay, so a couple things. First, the shape does not change in a sense that it's still a triangle. It still goes in the same direction. It's just that it's larger. Now, the reason that we want to write down our ordered pairs first is because there isn't like a pattern with how we went from C to C like this that fits the same as B to B. See how it's like up 2 over 1, B is up 1 over 2. There really isn't a pattern like that to follow because that happens with like translations or whatever. With our dilations, to try to mentally make all this happen, it's very hard. Not because it's challenging material, it's just a lot to expect our brains to do. So take your time. You have to write the ordered pairs anyway, so do them first. Let's look at another example. So let's get our ordered pairs dealt with first. It says draw the image after a dilation having a scale factor of 0.5. So we're going to multiply each ordered pair or each coordinate by 1/2. Okay. So m primes, we're going to cut everything in half. -6 cut in half is -3. I'm basically saying -6 times 1/2. It's -6 over 2, which becomes -3. 6 cut in half is 3, right? Or if you have to, grab a calculator and multiply by 0.5. A prime, cutting each of these in half, -1, -2. T prime, -1, -3. And H prime, -3, -3. Everything's times 0.5, cut in half. And then we plot our points. So m prime is -3, -2. A prime is -1, -2. T prime is -1, -3. Let me move this. Oops. And H prime is -3, -3. If I look, it's the same shape going in the same direction. It's just smaller. It's like a mini version of that rectangle. So what you'll notice is with my scale factor, in this problem, in example 2, my scale factor was below 1. If your scale factor is smaller than 1, we're going to shrink. If I look at example 1, my scale factor is larger than 1 and my shape expanded. So that's something to keep in mind. If the scale factor is going to make, if all my coordinates get bigger, so my coordinates for A went from 2 to 4, 3 to 6. So if my numbers get bigger, my shape will get bigger. Okay, in example 2, all my numbers got smaller, the digits, that is. Okay, the digits got smaller and the shape got smaller. Oops. All right, so let's take a look at our properties. Let me get this. There we go. All right. So pre-image and the image. So we want to compare the images. Are they congruent? They're not congruent. They're what's called similar. If two shapes are similar, they're proportionate to each other. Okay, the minute we have a scale factor, we're keeping our proportions. So they're proportionate to each other. The corresponding angles are congruent. Okay. And the corresponding sides are proportionate. And just a side note on similar. Similar means same shape, proportionate size. So what that means is if I look at my rectangle, look at our rectangles over here. This side right here is 2 units high. This side is 1 unit high. My top side here is 2 units high. My top side here is 4 units high. If I were to turn these into fractions, do you see how my larger rectangle would be 2/4 and my smaller rectangle would be 1/2? They're proportionate to each other. That's what makes them similar. Let's do another example. We're going to look at practice number 1. So for practice number 1, it says graph and label the pre-image and image after a dilation with a scale factor of 3. So let's plot the pre-image first. So A is -1, -1. B, -1, -2. And C, -2, -1. And I waited a second to label them because I wasn't sure what direction this shape would go in. Okay, so draw that and label it. Now, after the dilation, we have a scale factor of 3. So that means each coordinate is going to get multiplied by 3. It's basically what's happening here. So A prime is going to be -3, -3. B prime, I multiply each of these by 3. -3, oops, -6. And then C prime will be -6, -3. So we can go ahead and plot these. -3, -3. It's A prime. B is -3, -6. And C is -6, -3. And if you notice, they look like the exact same shape, just one is smaller than the other. I have a right angle here at A on both. So my angles correspond. My angles are actually exactly the same. My sides are proportional. For practice number 2, I want you to try on your own. Remembering our scale factor is 0.5. So it'll be 1/2 times x and 1/2 times y. So hit pause, and I want you to try this on your own. So just quickly for a second, double check that you got the same pre-image as I did, the EFG. Then hit pause again, and let's see how you do with the rest. Okay, so first let's double check your coordinates. Oops, sorry. So double check your coordinates right here. Make sure you got the same thing I did. And then we're going to go ahead and zoom in here because my picture is really small. Okay, so point E, or E prime, was over 2 up 1. Right? Now F prime was over 3 up 1.5. So you want to be very careful here. 1.5 is in between 1 and 2. Okay? And G was at 2, 2. So you should end up with a triangle that's in the same direction, same shape, but it's smaller. And that's it.